Hi, what we are going to do here today is create a simple blockchain application today and using Python programming language. And we'll wrap this blockchain inside an API that we'll build using the fast API. I'm just setting up the framework by installing the requirements. I'll tell you what all libraries I've used over here. So I've used IPython as a command line interpreter. Instead of Jupyter, I could have used Jupyter, right? You know what Jupyter is. It's a program language agnostic, right? This one I'm just using for Python. IPython is explicitly for Python. And here I'll be using my command line interface using that to run some commands. This was something I found from Google on how people are using it. So I found it very useful and lightweight. So I chose to use IPython. And for executing the Swagger UI, right, is for the fast API, I'm using UVCon. Um, yeah, there is also hypercon and all those methods you can try. Since I found a solution for UVCon, so I used UVCon over here. Most of these that I'm doing here is, I found a lot of material and references from internet. However, I've tried to just combine it together and build one solution. I hope I was able to build something that would look like an application on blockchain. So this is my first app. Um, Here's the Genesis block. Genesis block is the first message. This is how the format of the message will look like. I'm just writing down this format, what we are going to actually have in our blockchain message. So index will just give some starting number one to identify. Timestamp will be the current date time. The data will be the actual data or instruction or whatever the contract information. Proof is going to be some proof value to do some solve some mathematical puzzle. We'll come to that in the video, and the previous hash, because this is the first block, so it won't have any previous hash, right? Similarly, then next message index to timestamp data proof will be any random value, and previous hash means the previous hash of the Genesis block becomes the hash in the next block, and then the original hash value of that second block itself. We'll create a hash function, and that's where we'll create the hash value out of for that message. Similarly, then we'll go on proceed third message index 3 timestamp current time data. We'll just write third block. Proof will be some random number, and then we'll previous hash. We'll use a previous hash of the second block for the third block and the third block's hash value itself. So this is how the structure will look like, just to give you an idea. Okay, so far good. So now let's start. So we'll just import the libraries here that are required for this blockchain application. JSON, for JSON dumps. The date time. I'm using underscore. This is my personal choice. What I read was on the internet is that you can protect this using by giving a name prefix with underscore. So tomorrow, if you are using a pilint or something to scan your code, right? Not executing, but scanning your code, it warns you, right, that this is a protected variable or a name, and that's why I'm just using it. I'm taking this reference from our previous modules. So creating a class blockchain, initializing a constructor over here, and the list. The blockchain is nothing but a reverse linked list because it tries to connect to previous block and so on. Genesis block will be our first block. Now I don't have anything, so I'll write a function. It took me a lot of time to think through this flow. However, in the video, I've just tried to make it fast forward for the time, saving the time. However, it took me some time to understand how I'm going to create this Genesis block. So I created a function, create block payment, and in that self, then I gave data as a type string, proof as a type integer because we're going to do some mathematical calculation over there. Then previous hash will be string type, and then we'll have an index value, which is again an integer type. And we'll store this as a dictionary. Then I create a block. You remember I showed you the format. That is how we are going to create. So I'll just initialize that block. So this will be the so Genesis block will be the first block, and that will kickstart my blockchain creation, right, for this application. I'll have to convert this to string. It took me when I executed, it took me some time to identify this. So we are not going to use a datetime format. So I'll just convert these datetime into string. And now I'll initialize a Genesis block, and there I'll just give some random name as Genesis block to identify this is the first block. Proof I'll start with one. Previous hash will keep it zero because there's no hash value. And index I'll keep one because we'll have to increment this index value, so I cannot go with zero. So I'll have to start with one. Now the next function is to add this block, Genesis block, into our blockchain. So we'll use the chain.append method that is there under the blockchain. And this will add this block or every block into the blockchain. But right now we are doing this for the first Genesis block. Okay. Now the mining and validation part comes, right? So here we'll create a miner block for doing the mining and validation of the message. And then it will, you know what miner block does. Once it mines the block, it identifies this is the right block to be put in the chain. It validates and then sends that block into to the other nodes to be added into the chain. And every block then adds that message into their blockchain. In the miner block, we'll just have self and the data, and we'll create output as a dictionary. For the miner block to run that, it runs on a previous block always. So we'll need a previous block to mine that, and that block will get to know through the hash value. So let's create one method for that, getting the previous block. Now this again I found it on Google, right? I was about to write this in the same function, then I found a good solution where they've created a separate function to get the previous block. So it's just very simple. Uh, I'll just return the chain and the last element, right? So I'll just use -1, and then we'll go back to previous block. Get previous block. And the proof will be for the previous block. And index will be the length of the chain itself, and I'll add +1. This is where I was saying in the index I wanted to increment, so that's why in the Genesis block I made index equal to 1. I can also use previous block. You can choose whatever way you want to create the index. Now proof, we'll have to write a function for the proof. So as I mentioned, we'll write some simple mathematical algorithm to solve the puzzle. So right now on the proof, I'll just keep it blank, none, and let's write a simple method to do that. For what we need is previous proof, index, data, and the output will be in integer form. It's a mathematical value. I chose some random calculation. You can do square, you can do cube, you can do modulo, whatever you want. I just did simple, addition, subtraction to just create some gaming puzzle. But the puzzle should be that it should go through, start from the 1 to a certain number, and it should stop at certain point when it meets the requirement of the number, the matching number that you have to create, the matching proof. So I'll initialize new proof is equal to 1 and then check proof. I'll just set the flag to false. So every time when the condition meets, the requirement is met, this flag will be enabled to true. The match logic that I will use is, we'll write it in a separate function and then just call it over here. The calculation part, I'll just add it into this function. So what is to index data, and I'll say I'll just do +1 for new proof, +1 previous proof, and plus the index number, and plus I'll append it with the data. Okay. This is just you can choose any calculation you want, any mathematical puzzle you want to add over here. You can do that. I'm just trying to keep the logic very simple. And then we'll return this in an encoded form, of course. Again, I found this from Google. And now here we'll initialize this and call that method over here, the math digest. Right. Yes, this makes it pretty clear. So here it will check for the proof and the flag. Now we need to change the flag. So we'll need some hash value or hash code. I'll just use the hash code, and we'll use SHA-256 dot hex digest. This is the hashing, right? This is the normal hashing I showed you in the previous video. Now we'll set some condition, right? So using the if and that hash value, I'll say, I'll keep it simple. Uh, so I'll just check for these zeros. If it finds that, then it will be true. If I keep increasing this, my puzzle will become more and more difficult. So it's up to you. It will take more time to get the proof, and then I'll increment the proof. Right? So we can increase this value as much as we want to more and more. The more the value, the more complicated and difficulty the miner will be. For the miner, it will be. I'm keeping it very simple. This is something I just did the calculation. This is not for something from somewhere I picked it up. And here the flag will turn true. That's it. Okay, and we'll return this. Oh, I forgot return here, so I'll return this block. And then we'll call this function in the proof variable. So we'll initialize this and call this. I hope this works. As I said, I'm using IPython for just command line interface. Okay, you may choose to use anything. Uh, Jupyter, you can use Jupyter, you know, right? What it stands for is Julia, Python, and R. So it's language agnostic. However, IPython is explicitly under Python. I am IPython, and then I'll import blockchain. I've not removed this troubleshooting. I've just kept in the video for the sake of learning and understanding, so that I can myself remember what mistakes I had done. It actually took me 2 days to build this code, guys. I'm in the video. It's just showing 30 minutes of time, but however, it took me 2 days to build this logic. Now, I had been struggling to identify why it doesn't find this module in the blockchain, and I did some googling, and then finally I realized that the file name, right, the Falcon blockchain, it doesn't identify that because I've used Falcon hyphen blockchain. Okay, and that's what I need to use. However, that did not work. I don't know why, whether I have to use the file name as Falcon or I have to use the file name as blockchain, but I renamed the file from falcon.blockchain to just blockchain. And then one more error I found in the code, I had instead of equal to sign, I had used minus sign. So I just corrected that and then the code worked. Now I'll call this minor block and then we'll give some message and see if it works. So it gives me some value. Um, that means our puzzle is working fine, right? Let's see when we do the validations and all, will come to know. However, the code is working fine. The logic so far is good. Yeah. Okay. So next, so whatever after the genesis, whatever block we create, every block should have their own hash. So we create a hashing algorithm here. This is a function available on internet, even on the if you go on the cryptography side, you will find this. This code is available. I'm just using it as it is, with just change in the naming convention. The hash will be the output will be in a string format. So the encrypted block, I'll use JSON.dumps and the block, and we'll encode it. So this is a standard how this runs, and then we'll return the hash library. So I have actually tried to correct some problems over here. Though in the video I've removed that. It took me some time to identify what uh, in this minor block I have to use previous hash, then the block itself, and then the previous hash and the index value. Right. Um, Now we'll put this block in the chain. Now remember one thing, we are passing the whole block over here. Okay, and let's I'll show you how it works. This took me some time to get it right. It did not work out in one go. So this is the chain, right? This is our first Genesis block, and you see the previous hash is 0. Okay, I'll have to remove that print. I just use this to check what it is printing. We'll again run this. So this is our first block. Now let me create another block with some message, and this is our second block. If you see the previous hash, it's showing me object. Why is it showing me an object? Uh, okay, this was missing, so the hex digest missing, right? So now again we'll import. So I need to see the hash value, right? So the first block is 0. Now we are getting the hash value. Now I'll mine another block. Okay, again you will see the previous hash of the previous block, and the current hash is also generated, but we are not seeing it over here. But when I create another fourth block, it will have the hash of this third block. So the code so far is working fine, and see the proof. Check the proof value. Every time it is different, and this is our blockchain. So the chain method that we created, this is our blockchain. So we are appending into that chain. Remember, we are appending the chain, every block into the chain, and this is how it gets appended. So when I added a fourth block, again it got appended into the chain. So logic so far is working fine. Now we'll validate the block. Okay. Now again here I had to check out some references and some materials on internet. Again, how do we get this validation? However, I found a very short way right now. We are not creating a wallet over here. However, if we do that, then we have to do the whole signing and then verification of the message and then sending the message. There's no user concept right now I'm building. We'll just validate using just a boolean value, true or false, whether my block inside the chain is true or false. That this method, what I'm doing is it will validate if somebody has tried to change any value in any of the block, my whole chain will become false. It should become false. So that's the intent of creating this validate the chain method. And if I try to use any block value and then modify it, the hash will change. And it doesn't change just a part of it, it changes the whole entire hash value of that block. And once the hash value changes of certain block, the remaining next block will not have that new hash. So automatically the chain breaks. So that validation will go false. And that's what I'm trying to do here. Again, I found this logic on internet, right? Somebody had done very brilliantly. So I'm just using that with some logic of my own over here. So the current block in the chain will be the genesis block, right? That is will be the first block, and the index I'll give. Um, Now we'll have to loop through it. Yeah. So it will continue validating till it finds the block inside the chain, right? It will go through all the blocks inside the chain. So that is why this while loop will loop through each of the blocks. And when it goes to next block, it checks the index and we'll have a criteria here that if my block index, if my next block if the previous hash of my next block is not equal to the hash of the current block, then return false. So if user has tampered anything, the hash key will not match, and there the condition will go false. So this is the logic that we are trying to build. I hope you understood, right? So it loops through all the blocks and tries to match the hash key. So the next block should have the value of the previous block, the hash value. If somebody has tampered the message, the value will not match and it will return false. So it will perform all this, and then finally it will use the same hashing logic. If I want to change the value, it generates a new hash, right? So that is what this hashing will do. It should generate a new hash. I think just for the identification, I'll add the word new. Next, next. Next. Current loop. I'll use the same logic over here. If the hash code does not match, it will return false. It will go to the next block. My current block will be the next block, and so on. It will go next until it matches the condition and should return. I'm incrementing this, so I'll keep that one only, and it should return true. Yeah, let's run this. So first block, I'll mine another block, then I'll add another third block, and then I'll validate the chain. So the chain is valid, and we'll see the chain now. Let's try to modify the first message inside the chain. Uh, okay, okay, I think I did wrong. Okay, now you see the validation chain failed, so it returns false because we tampered the block, the data inside the block. the hash value will not change. Okay, so our code is working fine. That block validation failed when we tampered the block. Now I'm creating another pipe which is main, and in that I'll use fast API to create my endpoints. Through these endpoints, we'll be able to check on the Swagger UI how each of the endpoint we can be used and called. If I want to send and share this API, expose this API endpoints to some other application, then how it will be exposed and how it will look like. So I'm creating this for my own purpose. You don't need to do this. I'm just trying it out just for the sake of learning. Right. So the exercise is over, although I'm just trying to create a API over here. So one was a block mining. So that will be that will become one endpoint for me. So this is the status code it will return if the chain is invalid. So this endpoint will retain the actual data within the block. Whatever we mine, that information, that endpoint, this another endpoint will show that information. We use the same code, same error code. And we'll return this. Let's um, let's try if it works. So UVCon, I said I'm using UVCon. This is a standard library. You can use um, other types also. Okay, our application has started successfully. Now I'll go to the browser and launch the local host site and with the port 8000. Yeah, it works fine. So I'll try this out. So I'll click on try it out, and this is the first Genesis block. Now I'll create another block. I'll mine a new block. This is 10 bitcoins trolley execute, and you will see it is created. The block is created. Now I'll go and execute the second endpoint, and you will see the chain how it appears in the chain. You see there, the next block appears. Well, superb. So this is working fine. Now we'll add few more endpoints. So the next endpoint was uh, going to validate. So we'll call our validation endpoint over here, whether the message has been tempered and is it a valid block for the chain. We'll again use the same code as above. we go. Looks fine. I'll mine one ball of block over here. It's fine. It's a hash. Now I'll execute the chain. It adds a block to the chain. I must have clicked on twice. And it is validated. I'm not going to tamper the chain over here, and you can try that out. You can see if it works over here. I'm just showing it as a demo that whether it is working fine or not. I'll add one more and see how the blockchain keeps on incrementing. So the code is working perfectly fine here. So far, it's true. The chain is valid. Wonderful. And anything else I can add? Uh, Now there's one more additional endpoint I'm adding just to check the previous block. That is the last previous block that we created. You can keep on creating your endpoints. I'm just trying to build some logic to see what all possibilities are there that I'm trying to factor into this code. And I'll just return this block and get previous block method. Yeah, we'll just run one by one. So right now the Genesis block is the last block, first and the last block. I'll create and mine one block. I pay my electric bill of 20 coins. Perfect. My payment goes into the blockchain. Then I validate the payment. It's true, fine. And I'll check here. This is my last block payment that I created. If you want, you can type one more. One more. Let's say I'm sending 100 coins to real estate dealer. I'm buying some property. Assuming my coins value is very high, hopefully. And that payment goes into the blockchain. I execute to validate the chain. It's fine. And there you go. This is my last previous block. Perfect. So our code is working fine. The logic is good. Now we can do a lot of things here. Add wallet, create users. We'll see in the later examples. Thank you guys.